Speaking of vibrations, impact vibrations can be really useful as well, not just from hitting part of a damping-based texture, but also from feeling a stiff wall and making it feel stiffer. So there are a lot of tricks that we can do in haptic rendering that can make virtual environments feel a little bit different from what the basic equations might say. So in this case, let's imagine that you have a virtual wall like this one here, and the user is represented by this cursor here, and we're approaching this virtual wall. Now, our standard spring rendering, remember, was F equals minus kx. And when we did that, the force slowly increases the deeper you get into the wall. And that is a good thing, because if you try to suddenly display a very large force, it would be like having an infinite stiffness. And real objects don't behave like that, and it would be hard for the motor to keep up and actually render a reasonable wall. So if we wanted to display a large force just at the onset of contact to really give the user an idea that an event has occurred, then we can display vibrations. And here's just two figures which try to illustrate how this might happen. So let's look at this one first. Let's look at this first diagram. So here's an example, just the position of the user moving over time. And let's say the virtual wall is down here. So over here is a solid wall, and the user's moving over time. There's their velocity, is the slope of this, and they're inside the wall for this portion, and then they're outside the wall again. Well, as this happens, the user should feel no force when they're outside of the wall, and then when they're inside the wall, they're going to feel an increasing force, and as they start to leave the wall, it gets decreasing, and when they've left the wall, it's zero force again. And this relationship here is just due to this F equals kx program that we're going to write for our spring. But if we wanted to provide a little extra oomph upon entry into the wall, you can add on a vibration. So the idea is that you would take this nominal force and then you would add to it an additional force, which would be based on some vibration. And you could model that however you like. It could be a sinusoid, it could be some other function, as long as it decays quickly in time, because you don't want it to make it feel like the wall is vibrating. You just want to feel a little bit of contact event that occurs as you first touch the wall. This picture over here actually shows how they're added together. So here's another position versus time plot up here. And the idea is that upon this onset of contact with the virtual wall, you play a force. And that force is not just the F equals kx part, which gives you something proportional to the motion of the user. You also have this transient, which when you add that on to the nominal force, gives you a little bit of vibrations upon entry to the wall, but those quickly die out, and then the rest of the time it just feels like a spring. And this should make a virtual wall feel much more crisp than a motor would be able to normally provide if you were just trying to increase K in order to make a stiffer virtual wall.